Here we're going to learn how to find a missing side of a right triangle. Step 1, 90-degree rule. The two angles of a triangle, not counting the 90, have to add up to 90. So we basically have to answer the question 22 plus 1 is 90. You could subtract or you just do guessing, but you'll eventually find out that the other angle has to be 68. Those two numbers add up to 90, and that makes the whole triangle add up to 180, which triangles do in an angular sense. Now, once you've figured that, step 2 is to pick any angle in the triangle, either the 22 or the 68. Now, I could pick the 22 or I could pick the 68, but for no particular reason, I'm just going to pick the 22. The third thing to do is to label the sides hypotenuse, opposite, and adjacent. Here's how. The hypotenuse is the side not touching the right angle. Here's the side not touching the 90-degree angle. The opposite leg is the side not touching the chosen angle. Since we chose 22 to work with, then the opposite is the x. The adjacent leg is the side that isn't the hypotenuse or opposite, so whatever's left. Once you've labeled your sides, you have to make an equation out of one of these three options. If I were to make a sine equation, it would look like this, cosine would look like this, and tangent would look like this. I recommend hitting pause and analyzing all the details. And now, once you've labeled all those, here's what we're going to do. The sine, cosine, and tangent on the left side of the equation for 22 degrees, these are just numbers that your calculator knows. But if we want to solve for x, it's probably not a good idea to use the top two equations because they both have these unknown hypotenuses in them. We don't know the hypotenuse, so the best thing I can do here is use tangent. I'm going to now solve this equation to find out what x is. To do that, we're going to cross multiply. So put the trigonometric function over 1 and then multiply diagonally. 1 times x is x. Step 6 is to divide if necessary, but there's no reason to divide here because we've already solved for x. So just use a calculator and get an approximation. Type that in a calculator, it'll tell you that x is approximately 6.3. Here's the problem in its entirety if you want to pause and look at it. And now that we know that x is 6.3, we've solved this problem. Here's another example of how to find the length of the side of a right triangle. Same steps, here we go again. Use the 90-degree rule to find the missing angle. So 61 plus something has to equal 90. You can figure out by subtraction that that's 29. Pick any of the two acute angles. So pick the 29 or the 61, doesn't matter. I could pick the 61, but just to be different, I'm going to use the 29 this time. Pick one of them, doesn't matter which. We're going to use that angle to solve the problem. Label the sides based on the choice of 29. So the hypotenuse is the side not touching the 90-degree angle. The opposite is the side not touching the angle we chose, and the adjacent is whatever's left. Now I'm going to make all three of these equations again, but only one of them is going to be useful. You might want to hit pause here to analyze these in more detail. And now, you'll notice that the top and bottom equations have an unknown side in them, and I'm not going to be able to solve for x using either of those. So I'll use the one that I can use. Now, step 5 is to cross multiply, so I'm going to put the cosine over 1 and multiply diagonally. Step 6 is divide if necessary, but it is going to be necessary here because if we want to solve for x, we have to divide both sides by the cosine of 29. And now we know what x is. Type that in a calculator, and we find out that x is about 8.9. Here's the problem in its entirety if you want to pause and look it over. And now we know what x is. Finally, we're going to learn how to find an angle in a right triangle. This time, we're not looking to find a side length. So pick any acute angle that you want to find. Well, the acute angles here are this angle, which is a Greek letter delta, and this angle, which is a Greek letter theta. By the way, you don't have to use Greek letters. You could just call them A and B, but it's a tradition to use the Greek alphabet for angles for whatever weird reason, so that's what I'm going to do. Pick one of them. I've picked theta, and I could have picked delta, but I chose theta, and now we're going to label the sides. Again, the hypotenuse doesn't touch the 90. The opposite doesn't touch the angle we chose. We chose theta to work with, and the other side is the adjacent. Now you're going to make one of the same equations again. Here's all three. Again, you may want to hit pause and analyze the details. But as you can see, two of these equations involve the hypotenuse, which we don't know, so the top two equations are not particularly helpful. I'm going to use the tangent equation. Next, we're going to do something called an inverse trigonometric function. To find the angle itself, we have to do the inverse tangent of that fraction. Your calculator will do this for you, and once you type this in your calculator, you will find out that theta is a 64-degree angle. Watch the diagram here. We now know that that's a 64-degree angle, and we can use the 90-degree rule to find the other one. In other words, 64 plus the other angle has to add up to 90. Subtraction or a little guess and check will tell you that that other angle is 26 because 64 plus 26 is 90. And here's the problem if you want to pause and look over the whole thing.